Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. Today's lesson is confidence interval, the introduction of confidence interval. Mrs. Gallas wants to implement a new reward system. When a student does something great, they randomly pick a bead from the bead jar. If the bead is red, they get a piece of candy. If not, they don't win a prize. The question is, what are the chances that a student chooses a red bead? Each group will get a sample of beads and will create a confidence interval to estimate the true proportion of red beads. The group with the smallest interval that captures the true proportion wins a prize. I actually have a lot of not red bead, but I have a lot of jars with beads on it with different colors. Now, what this saying is, we don't really know the true proportion of red beads in the jar, but we can estimate it using a sample. So if I take 20 pieces of beads and I counted how many red there are, so let's say for example, I have 20 and 7 of them were red. That is 35% are red, right? And maybe if you do it, maybe other kids, if they take 20 beads in the jar, maybe they have 20% are red, 40% that are red, 50% that are red. We don't know at this point, but I am going to go on with the sample that I have, which is 7 out of 20, which is 35%. Now, I am not sure if the proportion, the true proportion of red beads in there is really 35%. It might be higher, it might be lower, but right now I have my sample, and this is called my point estimate. This is my estimation, right, for the true proportion of red beads. My population would be all beads in a jar or in the jar. Sample would be 20. My parameter, I don't know what that is, but I know that this would be the true proportion of red beads. My statistic is going to be 0.35 because I got 7 red out of 20. And of course, you could have your different number. Maybe you could have 40%, 50%, 25%. I'm not sure, but at this point, again, I'm gonna say it last time that we are only estimating. Now we're going to change your point estimate into an interval of value. So when you say interval, like say someone asks you, hey, how many shoes do you have? Oh, I don't know. I think I have 25 to 35 shoes, right? You are making an interval from 25 to 35. Right? How many pencils do you have, or how many dresses do you have in your closet? I don't think people actually count how many dresses or t-shirts they do, but if you estimate how many, maybe you'd say, oh, I don't know, I have 30 to 50 t-shirts in my closet right now, right? So that is what we call interval of values, and that's what we're going to be doing today. Okay, now we're going to change your point estimate into an interval of values by adding and subtracting some value from your point estimate. The number that you add and subtract is called your margin of error. You can choose any amount to add and subtract, but remember, the smallest interval that captures the truth is the winner. So last year what I did is, of course, I know the proportion of red beads in the jar, but I did a contest where I had everybody got 20, and then they guessed the proportion of red beads, and then the closest to the proportion, the true proportion, I think I gave them like a Starbucks card or something. Okay, so that's the idea of this entire lesson. Okay, so I'll pick margin of error. Right now I have 7 red beads, so maybe my margin of error will be plus and minus 5 red beads. So that's 7 plus 5, and then 7 minus 5. So my interval would be from 2 to 12, right? That's That's what I'm trying to say. And then if my interval, if I want to have a closer one, I'll probably use 2. So like 7 plus 2, and then 7 minus 2. That's 5 to 9, right? Or I could, what's 2 divided by 20? That's 0.10. Or I could say that my margin of error will be plus and minus 10, 0.10. That's only 2 more red beads, which seems possible. Okay? And again, no judgment in there. If you feel like you're going to use 5 more beads, 6 more beads, 6 more or less 6 beads, 7 or less 6 beads, that's up to you. Use your point estimate and chosen margin of error to write an interval that you think contains the true proportion of red beads. So I have 0.35 plus in minus 0.10. So I'm going to have 0.35 minus 0.10, that is 0.25, to 0.35 plus 0.10, that is 0.45. So right now, my interval is from 0.25 to 0.45 and anything in between. Yeah, and this is now what we call point estimate plus your margin of error. There you go. How confident do you feel that your interval captures the true proportion? Answer with the percentage. We could, up to this point, of course, we were going to be learning how to properly say what kind of confidence interval do we have. But for now, we can say, oh, I am 100% confident. But of course, it's impossible to say you're 100% confident, right? Because you didn't really count all the red beads in the jar. So maybe you'll be 50% confident, 60% confident, 80% confident. With that, I don't have any idea on how confident you are at this point. But for me, I would say that I'm a 90% confident, right? And when we say that in sentence, we say we are, or I can say I am 90% confident that the interval from 0.25 to 0.45 captures the true proportion of red beads, of course, in the jar. Okay, if you are 85% confident, then you would say I am, or we are 85% confident that the interval from 0.25 to 0.45 captures the true proportion of red beads in the jar. And you don't have to worry about how I got that 90%, right? Or what if I did 95%? Would I be correct? Yes, because up to this point, we're only guessing, we're only estimating. And of course, in the long run, we'll have a rule on what percentage or how confident we are with our answers. Okay, moving on, number 6. One of the groups got 0.27 to, or comma 0.33. That means 0.27 to 0.33 as their interval. What was their point estimate? Like, what was the middle number? Right, you know how I got in the top here? You know how I got 0.25 to 0.45? My middle number was 0.35. Right? That was my point estimate. So how do I get the middle number of the 0.27 and the 0.33? Right? Or like, what was the point estimate in it? What I would do is I would add the two numbers. So let's get the point estimate. I would add the two numbers and divide that by 2. So you do 0.27 plus 0.33 divided by 2. That's 0.30. So the middle number or the point estimate was a 0.3. Now, how do we get, you know how I did 0.35 plus and minus 0.10? 0.10 was, we call this as my margin of error. What's the margin of error in there? What's the number that I added to 0.30 to make 0.33? What's the number that I subtracted to 0.30 to get 0.27? This is kind of obvious, yeah? I added 0.03, right? So how do I get that though? We are going to get the margin error, we are going to subtract the two numbers and divide it by 2. So we have 0.33 minus 0.27 divide by 2, that's 0.03. So 0.30 is my point estimate. 0.03 is my margin of error. Okay, number 7. One group claims that the true proportion of red beads is 0.25 or 25%. Does your interval, my interval that I calculated in number 4, support or deny this claim? Support or deny. Is 0.25 inside or outside my interval? I'll repeat that question. Is 0.25 inside or outside my interval? And this is obvious that my interval contains the 0.25. So of course, I would support this claim. Yes, I would support this claim because my interval contain 0.25, right? So that's it. Moving on, important ideas section. What did we learn today? We learned a point estimate is provide us a reasonable estimate about the population parameter. We solve the point estimate. We solve that A plus B divide by 2. For our margin of error, how did we solve that? Oh, B minus A, right? B minus A divide by 2. Okay, that is our point estimate, and then that's our margin error. Okay, what else? We also learn how to interpret. We are blah, blah, blah percent, 90%, 95%. Let's leave it blank for now. We are blank percent confident that the interval from the smallest number A to the highest number B captures the true proportion or the true parameter, right? The true proportion of whatever is in the context. True proportion of red beads, true proportion of fish in the pond, true proportion of students who likes food in the cafeteria, whatever that is what we're trying to estimate. And then confidence interval contain a plausible values. Okay, so let's check what this is. A random sample of 100 adults, that's our N equals 100, are asked if they pay for monthly subscriptions that they do not use, like magazine, app, or online program. Simply many do because they have never taken the time to cancel the subscription. Like sometimes I do that. I subscribe to something like online and then I forget that I'm subscribed, but I don't use that anymore, right? A 95% confidence interval for the proportion of adults who to pay for subscriptions they do not use is from 35.2% to 54.8%. Or in decimal 0.352 to 0.548. Interpret the confidence interval. And we have here our 95% confidence. So we are 95% confident. It's not 90, not like before. We are 95% confident that the interval from 0.352 to 0.548 captures the true proportion of adults who pay for subscriptions they do not use. Okay, start writing. The context is a little bit longer. Calculate the point estimate and calculate the margin of error. So can I call it PE for point estimate? That is A plus B, so 0.352 plus 548 divided by 2. That is 0.45. So this is our PE, point estimate. And then my ME, margin of error, is 0.548 minus 0.352 divided by 2. That is 0.098. Am I correct, hopefully? Okay, so there you go. Based upon this survey, a reporter claims that majority of adults continue to pay for monthly subscriptions they do not use. Use the confidence interval to evaluate the claim. What do you mean by majority? When you say majority of the class voted for so-and-so. So majority means that more than half, right? Okay? So when we say majority, we really meant to say more than half or above 50%. Okay, now let's take a look at our interval. If you take a look at our interval, we have from 0.35 to 0.54. It did include 50%, right? Because the 50% is in it. But it says that above 50%. But our interval contains both above 50% and below 50%. So what we're trying to say here is, can we support the claim of the reporter? We cannot, because we can't support it because our confidence interval right now includes both below and above 50%. So I don't have convincing evidence to support the claim of this reporter. Okay, so because our interval contains values that are both above and below 0.5 or 50%, we cannot say for sure that the majority, I'll put above 50% of adults pay for subscriptions that they don't use. Okay? Or I could say here, we do not have convincing evidence to support the claim or the reporter's claim. if my interval, like if my interval are all above 50%, say my interval was from 60% to 80%, then I would have convincing evidence to support the claim. But right now, I don't have convincing evidence to support the claim because my interval includes both above 50% and below 50%. Okay? That's it, you guys. I hope that this video will help you answer the homework about confidence interval. And if you have any questions, please let me know as soon as you can. And I will see you guys on the next video. Bye.